Okay, so now we're going to talk about quasi-experimental designs. So these designs are getting stronger than our pre-experimental designs. So other limitations common in clinical practice might necessitate non-random sample selection from the population, non-random assignments of subjects selected to experimental controls, and what we're going to talk about right now are non-equivalent group designs. So non-equivalent control group designs. One group is formed, pre-tested, exposed to experimental treatment, and post-tested. And then another group is formed and not treated. So we have two groups, observation, treatment, observation, and then we have another group that doesn't receive the treatment. We have a within subject design, and we have a between subject design here. So we're looking at the treatment within one subject, it's observed, receives a treatment, and observed again, and we're comparing those results to a group that didn't receive the treatment. So this is a mixed design. It's within subjects and between subjects. The experimental treatment is the difference between the two groups from pre-test to post-test. And having a control group somewhat eliminates contamination of internal validity by the effects of history, maturation, and pre-testing. So having the control group helps us eliminate those internal variables. We still have problems to solve, including subject selection, where the group selected for convenience rather than on the basis of randomization or matching. The quasi-experimental design, you also have to be concerned about history, maturation, subject mortality. A type of quasi-experimental design that we're going to talk about is a time series design. This employs repeated measurements of the dependent variable over an extended period of time. It is a single subject or a small n subject design, so a small group or a group in general is called a cohort. So you're the first year cohort, that's your group. We're going to say this is an AB time series design, the simplest time series design. Repeated measurements of the dependent variable are made in the baseline design segment before the treatment is introduced, and then several more repeated measurements of the dependent variable are made in segment B. So if you look at the bottom, it's 4 observations, and then a treatment, and then 4 more observations. So repeated measurements or repeated observations. This study is within subject. We were just going from left to right. Each person participates in 2 conditions, the baseline and the experimental. Strength of this type of studies with repeated measurements of the dependent variable in the baseline, you have a relatively good control over threats to internal validity posed by maturation, pretesting, regression, and instrumentation, because you've done so many observations, because you do so many observations. Subjects act as their own controls during the baseline segments. The experimenter can examine their performance on the repeated measurements without an experimental intervention. The baseline data are stable, like I said. Maturation, pretesting, regression, instrumentation are not threats to internal validity because you do so many observations. Excuse me. So here are multiple baseline designs across individuals with multiple dependent variables. So on the y-axis, hours of hearing aid use. So basically, let's look at the top figure. They have baseline measurement without the hearing aids. Then the people get the hearing aids, and then they do a number more observations. So because there's so many observations, you can see that the treatment effect was real. A/B designs do have a few weaknesses. Even with a stable baseline, history might pose a threat to maturation. Adding a group of controls is a possible way to, again, improve internal validity. So what we have here is we've added a control group. And we've made it even better because we've randomly sampled. So again, we do repeated measures in the baseline treatment and then more measures for the experimental group. We're comparing it to a group that receives no treatment. So we have a within study design and a between study design, and we have that control group which strengthens it. They could also do a time series design. This is known as like a withdrawal design. So again, we have a bunch of observations, then we have a treatment, then we have some more observations. The treatment's then removed, get it, the withdrawal design, and more observations are made. This is a within subject test. We don't have a control group. But it's stable because you've made so many observations, and then you can see if the treatment really was effective. So then, let's say in that example we just looked at, if you took the hearing aids back, if you remove the hearing aids, where would we go back to baseline? Then you know for sure your treatment's effective. A time series design provides an in-depth analysis of behavior, but it's time-consuming and it's difficult to do with a large number of subjects. Direct systematic replication helps to alleviate the problem of the external validity, with different treatments and different treatment combinations applied to individuals to assess their relative effectiveness.